discuss about probability. So what is probability? Probability, that is nothing but a value in between to 0 and 1. So that a certain event will occur in between to 0 and 1, we are calling that as a probability. So for example, probability that a fair coin will come up head is 0.5. So when we are planning to write a mathematically, we used it to write probability of E heads equal to 0.5. So the next thing is, when we are flipping a coin, we are having a heads and a trial. So over very many trials, a fair coin should comes up heads half of the time and a trials half of the time. So if a fair coin comes up tails 5 times in a row, the chance will become heads is still 0.5. We can't think of a series of independent events of needing to catch up to the expected probability. Each of the trial is an independent for all others. So when we are flipping a coin, it is known as experiment. Even mutually exclusive outcome is called simple event. The sample space is the sum of every possible simple event. So to consider rolling a 6-sided dice, one roll is an experiment. The simplest events are E1 is equal to 1, E2 is equal to 2, and E3 is equal to 3, and E4 equal to 4, and E5 is equal to 5, E6 equal to 6. So when we are considering rolling a dice to expected a E6, that's nothing but a one event, we need to calculate the total sample space. That's all nothing but E1, E2, E3, E4, E5, E6. This all 6 possible outcomes. So the probability of this, it's nothing but probability roll of 6 equal to 1 divided by 6. So now we are a company, we made up of total 50 trumpet valves, which is used to determine one of the valve was defective. If 3 valves go into one trumpet, what is the probability that a trumpet has a defective value? So now we are going to calculate the probability of defective trumpet. So probability of E defective trumpet is equal to, so we have a 3. So into probability of E defective value is equal to 3 into 0.02. So the probability of this is nothing but a 0.06. So we have a permutation and combination in our probability. So what is permutation? Permutation is nothing but a set of object in an arrangement of the object in a certain order. So the possible permutations of letters are A, B and C is. So the permutation is a set of object, is an arrangement of the objects in a certain order. So the possible of permutation is A, B, C, which comes like this. So how to calculate the permutation? For a simple example like ABC, we calculate the number of possible permutation as n factorial. So ABC equal to 3 items. So 3 factorial is equal to 3 into 2 into 1 equal to 6 permutation. So when we are having a 3 letters ABC, the permutation of ABC, that is nothing but 6. So now simple example, the website requires 4-character password can be either be lowercase letter or digits from 0 to 9. You may not repeat a letter or number, but we can able to use the lowercase letters and 0 to 9. So now we are calculating that n or the number of objects of 26 letters plus 10 numbers equal to 36. So now we are just going to check the number of objects taken at time is 4. Plug those numbers into the formula. So 36 factorial divided by 36 minus 4 factorial. When we are applying the permutation, we are just crossing the repeated elements, and then now we are having 36 into 35 into 34 into 33. So the permutation of this number, that is nothing but 14,13,720 permutations.
So now the next example of permutation is how many 4-digit license plates can using the number 0 to 9 while it's allowing the repetition. So the total permutation of a set n factorial. Permutation taken or at a time given set n. This is for no repetition and this is for repetition formula. So after this, combination. So what is combination? Unordered arrangement of objects that are called combination. A group of people selected as a team, they are a same group no matter how they are going to order it. We are going to have a pizza which is having a half tomato and a half spinach. So same as half and a half. Either you can able to add spinach first or tomato first, or tomato first spinach first. So the no matter the order, it all belongs to the same group. That's what our combination is. So the number of combination of a set of n object taken or at a time is given by n factorial divided by or factorial into n minus or the whole factorial. So combination versus permutation. How many 3-letter combination can be made from the letters A, B, C, D, E? So now we are just making the permutation and the combinations. So permutation, where I am making a permutation formula with no repetition. So our probable outcome is 60. So now we are going to realize each row contains the same letter or not. So this is the combination. So 5 factorial divided by 3 factorial into 2 factorial. So the combination of outcome is 10. So this is permutation versus combination. The formula combination is something which is going to be not repeating. It's not depends on the order. But permutation is also depends on the order as well. So the concept of probability is combination of your combination and permutation.
Distributions. A distribution that is nothing but which is used to describe the probable outcome of a particular variable. So we have two kind of distribution, discrete, continuous. First we are going to discuss about our discrete distribution. So what is this discrete distribution? The sum of all individual probabilities must equal to 1. This is what our discrete distribution is. So we are having a discrete distribution which is classified into 3 kind. One is uniform, another one is binomial, and another one is Poisson distribution. So what is uniform distribution? The probability of outcome which will comes with the equal space. So for example, now I am planning to roll this dice. So when we are rolling the dice, our outcome may be 1, 2, 5, 6 like this. But our outcome but not come like 1.5 or 2.5 like this. So when we are rolling a dice, our outcome which is comes with interval of 1. So this is what uniform distribution is. So here we are having a outcome 1, either 2, 3, 4, 5, 6. So between 1 and 2 we have a distance space of 1. Between 2 and 3 we have a distance space of 1. Between 3 and 4 also 1, 4 and 5 also 1, and 5 and 6 also 1. So this is what our uniform distribution is. So then we are having something like binomial distribution. So this binomial means two kind of things: head or tails, on or off, sick or health, success or failure. So your outcome, it may be a head or it may be a tail. That's it. Not like uniform. It may be 1, 5, 7, 6 like this. But when it comes to binomial, it may be a head or it may be a tail. So Bernoulli trial is a random experiment which is used to check your possible outcomes. So success or failure.
So when you are trialing n number of time, that's nothing but it will follow our binary distribution. So the probability of success, that's nothing but a p is a constant. Trials are independent of one another. So now when we are planning to take the probability observing x success in n trials, the probability of success of a single trial, which we are denoting as p. So that we are just assuming that p is fixed for all the trials. So this is our final outcome and this is our formula, where n of x, p the power of x, and 1 minus p the power of n minus x. So this is what our binomial distribution formula is. So this binomial distribution, which will comes in the interval like this. So when we are just flipping the coin, how many times my tail will come and how many times my head will come. So when I am just flipping a coin for 10 times, so the probable outcome of 5 is head is 5 times. So now I am just making a binomial distribution formula n factorial. So where there is a 16 possible outcomes, so divided by x factorial 13 factorial. So my final outcome is 0.2.42. So when I am rolling a die for 16 times, so what is the probability that a 5 comes up? So now we are just rolling a dice, like I am just checking now what is the probable outcome of 5. How many times I can able to expect 5. So now the probable outcome of 5 is 0.242. So maybe this much percentage we can able to expect our 5. So when I am planning to apply binomial distribution along with Python, from the SciPy framework, we are importing binom, that is nothing but a binomial distribution, and I am just checking my how many times I can able to get my 3 or 5 like that. So the next thing is Poisson distribution. So this binomial distribution consider the number of success out of n trials. A Poisson distribution consider the number of success per unit of time over the course of many units. So the calculation of our Poisson probability mass function is E of x equal to mu. So now we are just assigning the lambdas equal to number of occurrence divided by interval is equal to mu. So now the equation becomes P of x equal to lambda the power of x e the power of minus lambda divided by x factorial, where e that is nothing but a Euclid's number, which is nothing but 2.71828 like this. So now I am expecting in a warehouse 8 deliveries in between the time of 4 and 5 p.m. On Friday evening 4 to 5 p.m. I am expecting 8 deliveries. So now what is the probability that only 4 deliveries will arrive between 4 and 5 this Friday? So now we are just going to calculate this. X is equal to 4, lambda is equal to 8. Now I am applying that to our Poisson distribution formula. So my final outcome is 0.0572. So when I am just getting cumulative mass function in my Poisson distribution, that is nothing but the sum of all the discrete probabilities, it's nothing but the probability of seeing fewer than the expectation. So this is what my formula is. So when I am applying the factorial to this formula, I am getting my final output. So in between 2, 4 and 5, how many deliveries I can expect? But my expected delivery is 8. So the next thing is continuous distribution. So now whatever we discuss is a discrete distribution. Now we are going to discuss about continuous probability distribution. That's all normal distribution, exponential, beta. So now we are going to discuss about normal distribution. So this normal distribution, that is nothing but this data source tend to be around a central value with no bias left or right, and it gets close to normal distribution like this. So these kind of graph which is known as normal distribution. So unlike discrete distribution where the sum of all the bars equal to 1 in a normal distribution, the area under the curve actually equals 1. So this is our binomial distribution, that is nothing but a discrete distribution, and this is our continuous distribution, that is nothing but our normal distribution. So this curve which we are calling that as a bell curve or a Gaussian distribution, which is known as a symmetrical. So asymmetrical curve actually display the skew, which is or not normal. So we are having a central line which may be your mean, median or mode. So left or lower we are calling as a lower tile, and the right side lower we are calling that as a upper tile. So now we are just calculating mu and sigma. So the next thing is, in our statistics section we are actually discussing about sampling, standard error and hypothesis testing to evaluate our experiments. A large part of the process is the main thing is in normal distribution is nothing but the standardization. So we are taking our normal distribution to make everything as a standardization. So where you having an output like 950, 970, 990, 1000 like this is actual normal distribution values. Now I want to convert into the standardized normal distribution. So I am just converting 0 plus 1 plus 2 plus 3 like this, and here negative values. So now it's all standardized. Actually everything is all related to each other. So when the lower tile value is minus 3 and the upper tile value is plus 3, where 3 and 3. So this is what standardization. So in normal distribution the main thing is all about the standardization. So the next thing we need to discuss about percentile is a way that we are telling what percentage falls below the particular value. So meaning a 95% value actually indicate 95% of all other data points which is going to fall below the particular value. So for example, we are just going to have a student score of 1700 for the SAT score, which is nothing but a 19 percentile. Then again I am just telling 90% of the students, they are actually scoring 1700 marks. So now we want to check how much normal distribution of a test point score with the user or the student scored based on the mean and standard deviation. So this is the formula where mu is our mean and the sigma, that's nothing but our standard deviation, and E and the pi are the constant values. So now to gain a specific value of x in our normal distribution, we are calculating the standardized value, and then we are determining x is nothing but the percentile, and we need to look at the Z table. So this Z table, that is nothing but standard normal probabilities, which is going to map Z score of the particular area of our normal distribution curve to the left and right to the score. So now we are just going to check the total area under 1. So probabilities are bounded by 0 and 1. So now these are the different tables which we are serving. So for this is all our Z value and this is all our scores which is having. So now the next thing is, now based on this kind of table we are just going to calculate something else. So now the company is actually hiring a database administrator. So now we need to give the standardized test application to measure the technical knowledge. The first applicant, Amy, scores 87. So now
can we able to expect AMI to be qualified? So now we are decided to get the population value. So based on the thousands of previous tests, we know that the mean score is 75 out of 100. So the standard deviation, that is nothing but 7 points. Now we need to first convert our AMI score to standardized Z score. So the standardized Z score for X and mu, that's nothing but a mean value and the standard deviation value. So now we are just getting our AMI standardized output, that is nothing but 1.7143. Then now I am just going to look up 1.7143 on my Z table. So when I am looking up 1.7143 on my Z table, 1.7, so my output which I am getting 0.95.